Let's go ahead for maths. We're going to do National 5 Maths Quadratics. We're going to try and go through the whole topic. We're going to do graphs of quadratics, completing the square form, solving quadratic equations by factorising, solving them using the quadratic formula, and some tricky questions where you need to form and solve the equations yourself before you even get into solving them. So let's get into it straight away. All of these examples are taken from Maths.Scot, an excellent website, so make sure you get on that for any extra revision, and look out for our app at the end of the month. Clelland Maths National 5 app is coming and it'll be completely free for you. Example 1. The point 2 minus 20 lies on the graph of a parabola with the equation y equals kx squared. Find the value of k. So sometimes they might even show you a picture like this and they might say, well, look, we've got a graph and we've got a chord. I don't know whether it's going to be something like this going through there. And it's going to say, look, we've got 2 minus 20. And it's saying find the value of k because it's y equals kx squared. This applies to all maths. If you've got a coordinate, you've always got a x and you've always got a y. That's x, that's y. The first one's x, the first one's y. So our formula's got an x and a y in it. We just substitute if we've got an x and a y. And if whatever we've got left over is going to be a k. So our y is minus 20 equals k is still hanging out and our x is 2 squared. So minus 20 equals 2 2s is 4, 4k. Solve that, divide by 4. Minus 20 over 4 then must equal k. So k is minus 5 because 4 5s is 20. And we're done there. Clelland Maths is sponsored by Lecky, the educational publisher for Scotland. Today we're going to look at practice workbooks for National 5 and higher maths. These are just £5.59 when you use the discount code ClellandMaths at leckyscotland.co.uk, and these are excellent because they have lots of questions topic by topic by topic. So as you're working through the year, you can revise and practice any topic you want and make sure you are comfortable with that topic. But also when it gets towards exam season, a practice exam paper right at the end to make sure you're ready for your exams. Just £5.59 when you use the discount code ClellandMaths. The links are in the description and down below. Example 2. The point minus 1, 9 lies on the graph of equation y equals x plus a squared plus b. Find the equation of the axis of symmetry of the parabola. Example 2. The point minus 1, 9 lies on the graph with equation x plus a squared plus b, and the equation of the axis of symmetry is x equal minus 3. Find the values of a and b. Again, I'm going to draw you this just to kind of illustrate what it's trying to say to us here. It's saying us that at minus 3, that's where the turning point must be. So it must go something like that. We don't know how it goes. It's just a quick sketch. That turning point could be above or below there. But it's the axis of symmetry there because that means it's symmetrical either side. It's the only place it happens is at the turning point. So since we know the turning point is minus 3, and we've done completing the square before, that means that a must be 3 because 3 minus 3 is 0. So we now know that y equals x plus 3 squared plus b. So now we've got an unknown at b, but we've got a point, minus 1, 9. Well, that's an x and a y, so we're going to sub that in. 9 is y equals minus 1 plus 3 squared plus b, because minus 1 is x. So 9 equals 3 minus 1 is 2, plus b, 4 plus b, so b equals 5, and we're done there. A, just to be clear, is equal to 3. Example 3. Find the turning point in the equation of the axis of symmetry of the graph, y equals minus 2, x plus 3 squared, minus 1. So this is already in completing the square form. That 2 doesn't really make any difference to it whatsoever, because at your turning point this bracket is 0, so minus 2 times nothing is nothing. So it's still just looking at that and looking at that. So our turning point TP is equal to minus 3, change the sign, plus 3 becomes minus 3, and minus 1. The axis of symmetry, well, that's told from the turning point, but the x part, x is minus 3. In other words, if we draw a graph of this, you've got a coordinate of minus 3, minus 1 there. Now I know it's going to go like this, but only because it's a minus 2 in front. That'll give you a minus 2x. That's the axis of symmetry, just that dotted line that cuts it in half. So that's -3 minus 1, and the equation of a vertical line is x equals a number, so it's x equals -3 because that's the coordinate of the turning point. Example 4. A parabola has a turning point of 2, 5 and passes through -132. Determine its equation. So let me just set this up as a wee sketch. It's got a turning point at 2, 5, so along 2 up 5. And it passes through the point -1, -32, let's say down there. So it probably goes like that, although it could go the other, it couldn't really go the other way. But that's basically what it's asking us. Now, you don't need to be able to set this up. You just need to remember that y in completely square form is k x plus p squared plus q. So not just x plus p squared plus q, because it could be times by some number, k some k. But we already know 2, 5 tells you these two numbers, because the k doesn't matter, because you make this bracket 0 at the turning point. So to get our p, our turning point we know is 2, 5, which means that p equals -2, the opposite of 2, and q equals 5. So we've now got y equals k x minus 2 squared plus 5. But we've also got another point, -1 and 32. Well, that's an x and a y as well, so I can sub in that for y and that for x. Quite a tricky question this, but let's just keep going. 32 equals k -1 minus 2 squared plus 5. So we solve that for k. So 32 equals -1 minus 2 is 3, squared is 9, k plus 5. Take away 5 from each side then to get 27. And therefore k must be 3. So the final equation is y equals 3 x minus 2 squared plus 5. I think that's quite tricky for National 5 Maths, so hopefully you managed to follow through with that, but don't worry if you didn't. Solving quadratics. Example 5, 2x plus 1 and 3x minus 10 equals 2, 0. So that means that each bracket equals 0. So we just say that and solve both of them. So that means that 2x is -1. So x is -1/2 is one solution, or 3x is 10. So x is 10 over 3 is the other solution. And we're done there. Solving quadratic equations by factorising. SB National 5 Maths 2018, Paper 1, Question 5. Solve x squared minus 11x plus 24 equals 0. So you should recognise that's a quadratic or trinomial because it's got an x squared, an x and a number. So since it's Paper 1, I know we're factorising most of the time because if we use the quadratic formula, we're going to get decimals. So unless it tells us to in Paper 1, factorises. Looking for a common factor, there's no common factor, so straight away it is double brackets. And this is quite a simple one. If it's just an x squared, I can write x and x straight away. To get my other numbers, I'm looking for two numbers at times to make 24, but add to make -11. So at the side, what you could do is write -11 and 24. Writing down all the factor pairs of 24, so 1 times 24, 2 times 12, 3 times 8, 4 times 6, and then I'm done. And you're looking for those pairs, can I add or take away to make -11? Well, I clearly can't do that with 24 and 1. I can do it with 12 and 2. No, can't do it. Can I do it with 3 and 8? Well, 3 plus 8 is 11, so yes, I'm going to be able to do it. And can I do it with 4 and 6? Nope. So how do I do it with 3 and 8 to make -11? Well, I need -3 and -8 to make -11. And just double check at the end. -3 times -8 is 24. So I've done it right. -3 -8. So we've got two brackets that equal 0. That means that x minus 3 equals 0 or x minus 8 equals 0. And just solving those equations, x must be 3 because 3 take away 3 is 0, or x must be 8 because 8 take away 8 is 0. And we're done there. SB National 5 Maths 2014 Paper 1 Question 13. The diagram below shows the path of a small rocket which is fired into the air. The height h of the rocket after t seconds is given by 16t minus t squared, which is a quadratic, and you can clearly see a parabola there. After how many seconds will the rocket first be at a height of 60 meters?
So for part A, it's telling us that h equals 60. So I just sub that in. I've got 16t minus t squared equals 60. So moving everything over so that it equals 0, I'll move it to the right so I get a positive t squared. So that gives me t squared minus 16t plus 60 equals 0. So all I've done is I've moved the minus t squared over to make positive t squared, and I've moved the 16t over to make minus 16t. I've now got a quadratic to solve, so I look for a common factor. There isn't a common factor, so I'll try and factorise it. Now, if it doesn't factorise, I'll use the quadratic formula. But there is paper 1, so chances are it will factorise. So double brackets, t and t. I'm looking for two numbers at times to make 60, but add to make 16. So I can make a little table with myself, 16 and 60. So 1 and 60, that doesn't work. 2 and 30, that doesn't give me 16. 3 and 20, that doesn't give me 16. 4 and 15, well, that doesn't give me 16. Eventually you'll get to 5 and 12. 5 times 12 is 60, but 5 plus 12 doesn't work either. And then you'll get to 6 and 10. And eventually 6 and 10, 6 tens are 60, plus 6 plus 10 makes 16, but we'll try to make minus 16, so it's minus 6 minus 10. Minus 6 minus 10. Now you might have got there quicker, and if you did, well done. That means that t equals 6 or t equals 10. So at first, how many seconds will it first be at a height of 60? The first one's 6, so our answer is t equals 6 seconds, and we're done there. So we highlight it and underline it. It now says, will the rocket reach a height of 70 meters? Well, the maximum it ever is the maximum turning point, which is here. So we need to work out where the turning point is and then find out whether or not at that turning point what the height is. So we know we've got 6 and 10. So for part B, our turning point happens at 10 plus 6 divided by 2. You add the roots and you half it to get the middle of them. 10 plus 6 is 8, divided 10 plus 6 is 16, divided by 2 is 8. So the turning point happens at 8 seconds. So when t equals 8, we have got h of t is 16t minus t squared. So when t equals 8, we've got that equals 16 times 8 minus 8 squared. That's 128 minus 64, which equals 64 meters. So then we just write a little statement. Max height equals 64. So rocket never reaches 70 meters. And we're done there.
Example 8, SQ National Applied Maths 2021, Paper 1, Question 19. Solve by factorising 6x squared plus 13x minus 5 equals 0. So if you're not sure how to factorise, look at my previous video, but I'll do it for this question. So if you're not sure on factorising, look at my previous video on factorising, but I'll do it for this question anyway. So this is a non-monic trinomial, which means there's no common factor, and I've got a number here instead of just x squared. So my method is I times the 6 and 5 together to make a new number, and that's my target number of minus 30. But I've still got to add to make 13. So I'm looking for two numbers at times to make 30, but add to make 13. You can try numbers like you could try 10 and 3 and see if that works, but if you try that, you try to make minus 30, so 1 must be minus. If I do minus 10, add 3, don't get 13. And if I do minus 3, add 10, I don't get 13. So it's almost right, but not quite. So I'll try another combination, 15 and 2, say. Well, if I did plus 15 minus 2, I would get 13, and plus 15 times minus 2 is minus 30, so that's the one I want. So I draw my grid. 6x squared plus 15x minus 2x, and then I've still got minus 5. I factorise the top line, so 6 and 15 is 3x. 3 times 2x is 6x squared. 3 times 5 is 15. And 2 times minus 1 is minus 2. So you get 2x plus 5. 3x minus 1. And if this was a factorised question, I'd be done. But it says solve, so equals 0. So that means that each bracket equals 0. And now we can just solve both equations. So looking at the first one, 2x gives you plus 5 becomes minus 5 divided by 2. Or 3x minus 1 equals 0. So 3x is 1. So x is 1 over 3. And we're done there. Example 9, the sum of a negative number and its square is 110. Use an algebraic method to find the number. So let's say that x is the number. X is the number. And let's see if we can translate the question into a problem. So it says the sum of a negative number called x, and its square plus x squared, sum means add, equals is 110, equals 110. Okay, so there you go. We have got a quadratic, so we can solve that. Rearrange that, x squared plus x, take the 110 over, because whenever you're doing an x squared sum, you make it equal to 0. So I'm looking for two numbers at times to make 110, but add to make 1. Now, you need to be able to count a little bit for this one. 10 times 11 is 110, and obviously 11 and 10 make 1 when you do plus 11 and minus 10. So that means you get x equals 10 or x equals minus 11. But we need to go back to the original question. The sum of a negative number. X is the negative number, so x can't be 10. So the only answer in this case, even though you always get two solutions when you do quadratics, is x equal minus 11 because we're rejecting 1. Solve 3x squared minus 4x minus 2 equals 0. Given the solution is correct to 2 decimal places. So it's asking for 2 decimal places, so it can't be factorised and it must be the quadratic formula. So it's checking the start of the exam paper. You've got x equals minus b plus and minus the square root of b squared minus 4ac all over 2a. And your a, b, and c are the number in front of x squared, the number in front of x, and the other number. So there's your a, b, and c there. So we can just sub that in, watching your signs, minus b, so minus, then minus 4 again, plus or minus b squared, minus 4 squared, minus 4 times 3 times minus 2 all over 2a, 2 times 3. So tidying that up, minus minus makes plus 4. And then always do the square root bit. So in my calculator, I've got minus 4 squared is 16. 4 3s is 12, 12 2s is 24. And it's a minus times a minus is a plus. So I've got 16 plus 24, which is 40. So that gives me a square root of 40. And that bit's called the discriminant, which is handy later for when you're doing nature of roots. So there we go. We've got 4 plus or minus 40 rooted over 6. So we can set up out of 2. So we've got minus 4. We've got 4 plus root 40 over 6. And 4 minus root 40 over 6. Now we just get a calculator to work that out. So 4 plus root 40 equals divided by 6. 4 plus root 40 equals divided by 6 equals 1.720. A few other numbers. 4 minus root 40 divided by 6 is minus 0.387 with a bunch of other numbers. They usually ask you 2 decimal places. So this one, 1.72, and this one, minus 0.39. And we're done there. When determining the nature of the roots of the function, x squared minus x plus 3. Nature is determined by the discriminant. That's the bit under the square root sign in the quadratic formula, which is b squared minus 4ac. Now, because that's under a square root sign, there's lots of things that could happen. 3 things, actually. If this whole thing's negative, you try to square root a negative. Well, you can't do that. So there's no real roots. We say real because there is imaginary ones. You'll find that out in A6. If you get 0, when you're square rooting a 0 and adding and taking away 0, so you're only getting one answer. So we've got one answer, but there's actually 2 answers. They're just both the same. And if it's positive, you're getting 2 answers because you get a positive and negative answer when you square root plus or minus a number. So that's the kind of idea. So A is 1, B is minus x, so that's minus 1, C is 3. So b squared minus 4ac minus 1 squared minus 4 times 1 times 3. That's 1 4 threes is 12. That's minus 11. So since b squared minus 4ac is negative, less than 0, there are no real roots. You need to say real, no real roots. If you say no roots, you'll lose marks because it's actually not true mathematically. You need to say no real roots.
It's great. National 5 Maths 2016, paper 1, question 6. Determine the nature of the roots of the function 7x squared plus 5x minus 1. So nature of the roots is the discriminant. You can find the formula for quadratic formula at the start of the exam paper, and it's a bit that says b squared minus 4ac. So I want to look at b squared minus 4ac. So a is 7, b is 5, and c is minus 1. So summing that in, we get 5 squared minus 4 times 7 times minus 1. That gives me 25. 4 sevens is 28, but a minus times a minus is a plus. So it's plus 28. Be careful of that. Now I need to do 25 plus 28. Well, that is 53. And then we need a statement. So there's 3 options. If b squared minus 4ac is positive, it's got 2 real and distinct roots. If it's equal to 0, it's got 2 real and equal roots, or 1 real and equal root. And if it's negative, it's got no real roots. So since b squared minus 4ac is greater than 0, it has 2 real and distinct roots. Well done there.
Example 13, determine the nature of the roots of the function x squared minus 6x plus 9. So a is 1, b is minus 6, c is 9. So we do our b squared minus 4ac, which is the discriminant. So that's minus 6 squared minus 4 times 1 times 9. That's 36. Minus 4 times 1 is minus 4 times 9 is minus 36. So that's 0. Since b squared minus 4ac equals 0, there are 2 real, always need to use the word real, and in this case equal roots. In other words, they're the same. Now, if you don't want to use 2 real and equal roots, you can say 1 real repeated root. But you're saying it's repeated, it's twice. But I prefer 2 real and equal roots because all quadratics have 2 roots. SQA National 5 Maths 2023, paper 1, question 5. Determine the nature of the roots of the function 4x squared plus 6x minus 11. SQA National 5 Maths 2023, paper 1, question 5. Determine the nature of the roots of the function 4x squared plus 6x minus 1. So that is using the determinant. The determinant is in the quadratic formula, b squared minus 4ac. So I'm going to look at b squared minus 4ac. So a equals 4, the number in front of x squared, b is 6, and c is negative 1. So that means I've got 6 squared minus 4 times minus 1, 36. And then you've got 4 times 4 is 16, times 1 is 16, minus times a minus is a plus, so plus 16. 36 plus 16 is 52. And then we need to make a statement. Now the statements are if it's positive, negative, or 0. So since this is positive, since b squared minus 4ac is greater than 0, there are 2 real, you need to use the word real, and distinct roots, or 2 real and different roots. Example 15, SQA National 5 Maths 2013, specimen paper 2, question 12. Find the range of values of p such that the equation px squared minus 2x plus 3 doesn't equal 0, where p doesn't equal 0, has no real roots. I think it's quite a hard question. It was in a specimen paper, so it could technically come up, but I think it would be grade A if it did. Let's just walk through it. B squared minus 4ac. Well, A is p, because it's px squared. B is minus 2 and c is 3. So I've got minus 2 squared minus 4 times p times 3. And it says no real roots. If it's got no real roots, that's less than 0 is what you had to realise, because no real roots means it's negative. So that's 4. 4 times p is 4p times 3 is 12. So 4 minus 12p is less than 0. So we've got an inequality to solve. So 4 is less than 12p. So dividing by 12, 4 over 12 is less than p. That's 1/3 is less than p, or a nicer way to read that is p is bigger than 1/3. And we're done there. Example 16. A function is defined as ax squared plus bx plus c, where a doesn't equal 0. The graph of y equals f of x has a turning point at 5, 0. State the value of b squared minus 4ac. So it's trying to get you to realise this again. Quite a hard question, probably grade A. Can you translate the graphs with the maths? So let's draw a quick sketch of what it's telling us. At 5, along 5, 0, that's a turning point. Y and x. So if that's a turning point and it's a quadratic, remember quadratics have a one turning point. It looks like that of that. So it's either going that way or it's going that way. And it doesn't really matter which way you draw it, just to get my sketch, I'll just draw a normal one. It's turning that turning point, which means it's only touching the x-axis at one place. If it's touching the x-axis at one place, it means the discriminant must be 0 because it's got two real and equal roots. So if you get the discriminant 0, it means your turning point is on the axis. Quite important that. That means that b squared minus 4ac equals 0. And we're done there. SQA National 5 Maths 2023, Paper 2, Question 14. A storage unit is built in the shape of a cuboid as shown. It has a length of x plus 7, a breadth of x, and a height of 2, and the volume is 45. We have to show that 2x squared plus 14x minus 45 equals 0. Relatively standard question this by now. We can write an expression for the volume and make it equal to 45. So the volume of a cuboid, length times breadth times height. So let's just write that down. We've got x times x plus 7 times 2, and that equals 45. So expanding the brackets, well, we've got 2x times x plus 7, I suppose, equals 45. 2x times x is 2x squared. 2x times 7 is 14x, and that equals 45. Or taking the 45 to the other side, we get 2x squared plus 14x minus 45 equals 0. And we're done there. Part B, calculate x, the breadth of the storage unit, give your answer to 1 decimal place. So the hint here is it's a quadratic. 1 decimal place means we're using the quadratic formula. So from the start of the exam paper, x equals minus b plus or minus the square root of b squared minus 4ac all over 2a. And in this case, my a is equal to 2, my b is equal to 14, and my c is equal to negative 45. So we get x equals minus 14 plus or minus the square root of 14 squared minus 4 times 2 times 45, what's a minus 45, all over 2 times 2. That means that x equals minus 14 plus or minus the square root of, you get your calculator out and work out 14 squared minus 4 times 2 times minus 45. You've got 196 for 14 squared. 4 times 45 is 180 times 2 is 360. Minus times a minus is a plus. So it's plus 360 all over 2 times 2, which is 4. So we get x equals minus 14 plus or minus the square root of 556 over 4. So we get a calculator out for x equals minus 14 plus 556 over 4. And x equals minus 14 minus root 556 over 4. So using our calculator, for the first one, bracket minus 14 plus the square root of 556, all divided by 4 is 2.39, ... but to 1 decimal place, 2.4. And then for the other one, we've got minus 14 minus root 556 divided by 4. We've got x equals minus 9.39. And I'm not even going to round that one because this is a round for breadth, so that isn't the one we're going to use because you can't have a negative length. So therefore our only answer is 2.4 metres and we're done there.
Maths 2024 paper 2 question 8. Solve the equation 3x squared plus 8x plus 1 equals 0. Give your answer correct to 2 decimal places. Well, this is a quadratic, so I use a quadratic equation, quadratic formula, sorry, because it says give your answer to 2 decimal places. So start of the exam paper says that x equals minus b plus or minus the square root b squared minus 4ac over 2a. So in this case, a is 3 because it's the number in front of x squared, b is 8, it's the number in front of x, and c is 1. So x equals minus 8. Make sure you put this in right. Square root 8 squared minus 4 times 3 times 1 all over 2a, 2 times 3. So that is minus 8 plus or minus. You usually get a mark for working this bit out. So I'll work this bit out. 8 squared minus, I'll put a bracket, 4 times 3 times 1 is 52. 2 3s is 6. So that gives me minus 8 plus root 52 over 6, or minus 8 minus root 52 over 6. So I'll work them out separately. Minus 8 plus root 52 over 6 is always going rounded first, minus 0.131, which to 2 decimal places is minus 0.13. So there's my first answer. Second answer, minus 8 minus root 52 all over 6, or x equals minus 2.535, or a bunch of other numbers, but to 2 decimal places, that's minus 2.54. And we're done there.
Screen National 5 Maths 2025, Paper 1, Question 9. The diagrams show the parabola with equation of the form x plus a squared plus b. It says find the value of a and b. So all you need to remember is that one changes sign, so it's minus 3, so it changes back to 3. And this one does not change sign, so it's still just minus 5. So b is minus 5. SBA National 5 Maths 2025, Paper 1, Question 11. Determine the nature of the roots of 3x squared plus 2x plus 1. So I'm looking at b squared minus 4ac for this. So a is 3, b is 2, c is 1. So I've got 2 squared minus 4 times 3 times 1. That's 4 minus 12, which is minus 8. So since b squared minus 4ac is less than 0, there are no, you need to use the word real, roots. And we're done there. SBA National 5 Maths 2025, Paper 1, Question 15. The diagrams of a rectangle and square are shown, all measurements in centimetres. Find an expression for the area of the rectangle. Well, area is length times breadth, so I've got L and B. So that's just 2x plus 3 and x plus 1, and it's only worth 1 mark, so I don't think I need to expand it or anything. So we're done there. Given the area of a rectangle equals the area of a square, show this. So this is your standard thing. There's my area of a rectangle again. And that equals the area of the, and it says it's a square, so that's x plus 3. So that's x plus 3 times x plus 3. Or x plus 3 all squared. So expanding the brackets any way you want, I'll use my grids. 2x plus 3, x plus 1 equals x plus 3, x plus 3, 2x squared plus 3x plus 2x plus 3, x squared plus 3x plus 3x plus 9. So that gives me 2x squared, 3 plus 2 is 5x, and then plus 3 on the left, and then x squared, 3x plus 3x is 6x, and then plus 9. So moving everything over, 2x squared minus x squared is just x squared on this side, 5x, then take away 6x is minus x, and then 3 take away 9 is minus 6 equals 0, and that's what we want to show. But remember, if you can't do this question, you can still do part C, because you're just solving it. So part C says, hence find algebraic with the length and breadth of the rectangle. So we've got x squared minus x minus 6 equals 0. A quadratic equation, and since we're on paper 1, it probably factorizes. Double brackets, x and x, two numbers at times to make 6, but add to make 1, well that's 3 and 2. And I want minus x, so minus 3 plus 2 is minus 1. So that says that x plus 2 equals 0, and x minus 3 equals 0. So x equals minus 2, and x equals 3. But we can't have that because you have to have, can't have negative lengths. So we're going to use 3. So then we need to actually work it out. So way back up here, we've got length is 2x plus 3 and breadth is x plus 1. So our length was 2x plus 3 and our breadth was x plus 1. So we're using x equal 3. 2 times 3 plus 3, 6 plus 3, 9 centimetres. This one, 3 plus 1, 4 centimetres. And we're done there. This is my Quadratic Maths, and today we've done the whole quadratics in National 5 Maths, looking at graphs, looking at turning points, looking at solving quadratic equations, looking at forming equations. Hopefully you found that useful. Take care, stay safe, and goodbye.